Hello everybody, I'm here with a very simple example of how you can determine the moment of a couple that is formed obviously with two forces. In the previous video I talked about what is a couple, define the couple, and how do you determine moment of a couple. Remember, couples are formed by two forces that are equal in magnitude, so you see 10 kilonewtons here. They're opposite in sense, as you could see in the picture, and they are parallel. So you could see that these two forces obviously are parallel, so they have the same slope, the slope of 4/3. And normally, if you want to find moment of a couple, and that's what we are trying to determine here, how would we do that? Moment of a couple is independent of the point that you're taking moment about. So it's just F times D, where D is the perpendicular distance between the lines of action of two forces. So if you could figure out what D is, then you're all set. Of course, I'm not going to do it that way. I could actually show you how you can get D after I calculate the moment of the couple for you. But we're not going to do it this way. So let me just erase this. Basically, what you want to do in a situation like this is to break the force, as you could see, easily into two components. So for example, this force has a horizontal component, and this force has a horizontal component which is exactly the same. And it turns out that this force, the x component, is 10 times 3/5, right? Which happens to be 6 kilonewtons, and the same thing here, 6 kilonewtons, right? And similarly, let me use a different color. This one is 10 times 4/5, which happens to be 8. And look, this one is also 8. So now you see, I have two pairs of couples. One are the yellow or orange vectors, right? 6 and 6, right? And I could go ahead and find the moment of this couple by finding the perpendicular distance between these two. You could see that actually that happens to be 2, right? So the way I'm going to do this is going to say, okay, let me pick a direction for myself. Let's say clockwise is positive. So what is the moment of the couple formed by these two forces? The 6 kilonewton force is 6 times 2, right? Times the shortest distance between the lines of action of the two 6, right? But that's going counterclockwise, so it would be negative. So in other words, if just look at the 6 and 6, how would that rotate? It would rotate it counterclockwise, so that's negative. On the other hand, the pairs of 8 kilonewtons, what is the shortest distance between them? You could see that's actually 4, right? But that's going to cause a clockwise rotation, so that would be 8 times 4, positive. So overall, I get a 32 minus 12. So my moment of this couple becomes 20 kilonewtons meters and clockwise. So now look, guys. Once you find the moment, if I could erase this for you, right? Take a look at this. Remember at the beginning I said, oh, if you happen to know what is this perpendicular distance, right? D, then the moment is what? F times D. Well, guess what? Then D is equal to moment divided by force. And moment already calculated to be 20 kilonewton meters divided by force, which is 10 kilonewtons in magnitude. So clearly D is going to be 2 meters. So that's going to be the shortest distance. Of course, in the beginning, it wasn't possible for us to quickly determine that distance. So you see how we broke this into components, and we basically had two pairs of couples, and we found the resultant of those two. Now, one thing I forgot to mention actually in the first video when I defined the moment of a couple and what is a couple, as an example that we see, whenever we have a problem with the, with a flat tire in our car, is that whenever you're trying to change a flat tire, so if this is the wheel of your car, right, and normal, we have what, 5 nuts, right, 5 bolts, nuts, right, and let's say you want to change, open or tighten a bolt. So what do? You have a wrench, right? You put the wrench here, right? So just concentrating on this one. And then what do? You apply force like this. Of course, in this direction, you're basically trying to tighten if you apply force. And then this distance is D. See that? That's a practical example of what moment of a couple. And what is the moment of a couple? The torque that is generated to tighten this bolt is F times D. So that's the magnitude of the couple. Let's say if you're putting 10 pounds using the strength in your arms, right? And then this distance is what typically? I would say for maybe 2 feet at most. So you're talking about 10 pounds times 2 feet, right? So we're talking about a torque of 20 foot-pound or pound-foot, which if it's applied like this, clockwise, you're tightening the bolt. If you do it counterclockwise, you're trying to loosen the bolt. Okay, guys, as always, if you like these videos, please subscribe to my channel. And as you could see, I'm trying to, make weekly videos, especially during this pandemic that we are online. And I'm teaching actually 3 courses this semester. One is statics, one is mechanics of materials, and one is a more advanced level course which deals with vibrations. So I'll try to put a video every week, or at least one video a week. Again, thanks for watching and listening.